page 2 of the Right Triangle Trigonometry Word Problems notes. We left off here, right? We got an isosceles tent. There is a question just like this on the, if you want to call it homework, on what you start in class today. So I'd put a star next to it because it is the same idea. It's notes from yesterday, my guy. Notes from yesterday.
Wait, which notes were they?
Yes. Alright, so you buy an isosceles style tent with equal sides of 6 feet. Pause. What does isosceles mean to me? Two sides are congruent. And what shape is it going to be? You know, like a triangle? Okay, two sides are congruent, and guess what? They're 6 feet. So in this one, we don't necessarily have a right triangle off the bat. We got an isosceles triangle, 6 feet, 6 feet. The base of the tent is 10 feet long, so the whole base is 10 feet long. Okay, find all of the angles. I need you to remember that SOHCAHTOA only counts towards a right triangle. So here is what we can do. This is an isosceles. These two sides are the same length. So here's what we can do. If we draw a line straight down, okay, perpendicularly with this guy, there's this thing called a perpendicular bisector, and that means the bottom line has been split in half. It means it is perpendicular to the base, all that jazz. So now you have two right triangles, and they are identical to each other. I know that my picture does not make them look identical. But because one is 6 feet and 6 feet, that means that top vertex is in the dead center of this bottom line. Even though I didn't draw it great. Okay, you got two right triangles. So think logically, if the whole length of the bottom of the tent was 10 feet, what are each piece now? 5 and 5. Okay, now we have two right triangles that are identical. So here's what we're going to do. We're going to focus in on one of them. Well, let's go back for a second and review. If you have two congruent sides, how many congruent angles do you have? You have two. And they're always, every side corresponds with the angle across from it. You still need to know that fact, and you still need to use it today on your homework. Every side corresponds with the angle across from it. So because I have two congruent sides, that means I have two congruent angles. These bottom angles are the same. So here's our thought process. If we find one of them, then we know the other. Then we would have two angles out of 3. And what do we know about the 3 angles in a triangle? They add up to 180. And that is our goal. Find all of them. So if we find one, we know the other. Then we add, subtract from 180. So we're going to find this bottom angle because we know this angle will be the same as this one. And we'd be able to find that top angle. Okay, so step 1, find this angle. Can I use the Pythagorean theorem to find an angle? No. We're going to use a trig ratio. So from this angle, what kind of side is 5? Adjacent. And what kind of side is 6? So which trig ratio are we going to use? Cosine. From the angle we don't know, you can call it x if you choose. Equals the adjacent, 5, over the hypotenuse, 6. I want to get x by itself. How do I remove that cosine? What do I have to type into my calculator? You got to use the inverse. So I'm going to use shift cosine of 5 over 6. What do we want to round to? A whole or a tenth? Sure, let's round to the tenth. What do we get? 33.6. So somewhere, we're going to write all the answers. 33.6 degrees. So we just found that bottom left angle. So remember, big picture. We had an isosceles triangle. That means if the bottom left is 33.6, the bottom right is also 33.6. So add them and subtract from 180 to find out what that top angle is. Something 0.8. 112.8.
This calculator is absolutely terrible.
Okay, I want you to take out the triangle paper from yesterday. I had some of my classes write something in that I think that was helpful to them, so I'm going to have you write it in as well. So before we're not doing this question right now. We are going to in a second, but your triangle paper looked like this. You had a bunch of lines. I drew that pretty well. Look at that. So what you're going to do first is we're going to label what would be the angle of depression and what would be the angle of elevation. So the angle of depression is always from the top of an object. There's always a horizontal line. Usually it's an invisible horizontal line, an understood, if you will, horizontal line. Okay, and then go ahead and label this as the angle of depression. Okay, so you had an angle of depression. You also had an angle of elevation. The angle of elevation is always attached to a horizontal line and opens upward. So this bottom one is the angle of elevation. I know I wrote it super tiny. This bottom right angle is the angle of elevation. So this top angle is nothing. Never anything. Nothing important. Okay, so angle of depression, angle of elevation. We're going to go back to our skiing question. Ready? You are skiing on a mountain with an altitude of 1,600 feet. So yesterday when we did these, we know it's going to end up looking like a right triangle. Okay, an altitude of 1,600 feet. What is another word for altitude? Height. So where does the height always go?
The left.
Yeah, the vertical one. So 1,600 feet. Boom. The angle of depression is 32 degrees. The angle of depression is the angle at which you go down a mountain. Okay, so you have an invisible horizontal line. That is the baseline for your angle of depression. Your angle opens up downward. This is 32 degrees. That means you're going down the slope at 32 degrees, which is like a baby slope, if you ask me. Find the distance that you ski down the mountain. Now, are you skiing on a flat surface or are you skiing on a diagonal surface? Like a diagonal. So we're trying to find this guy. Okay, so here's what we need to do. What do we know about the angle of depression and the angle of elevation? They're congruent because they're alternate interior. So we can mark this as 32 degrees as well. So from here, we're going to solve. I'm given an angle, so I can't use the Pythagorean theorem. I'm going to use a trig ratio. What kind of side is 1,600? Opposite. And then x is hypotenuse. So which trig ratio is this? Sine. From 32. So we're coming from this 32. Equals the opposite, 1,600, over the hypotenuse, x. Do I need to flip this?
Yes.
I do. 1 over sine of 32 equals x over 1,600 times 1,600 times 1,600. It doesn't say what to round to. Let's round to the nearest whole number since we're skiing. 3,019 feet.
Whoa!
A fire truck extends the 105-foot ladder against a 56-foot tall house. What is the angle between the ladder and the ground? So we've got a right triangle somewhere. Where is the ladder always going to be? The hypotenuse is always the ladder. And in this case, we already know the length of the ladder is 105 feet. Then it says, against a 56-foot tall house. It is on the left. It is a height. It's also just, it's leaning against the house. Houses are up and down. There you go. What is the angle between the ladder and the ground? Where is the ground located? The bottom. So this is the ground. So our angle is between the ladder and the ground. So we're finding this angle. Okay, so we're going to use a trig ratio because we're finding an angle. Which one are we going to use? Sine. 56 is opposite, and 105 is my hypotenuse. So we are going to use sine from an angle. I'm going to call mine x. Equals the opposite over the hypotenuse. Shift sine of 56 over 105. We can round to whatever you want to round to. 32 degrees.
Oh wait, so if we don't know the angle that goes to sine, we do shift sine?
Anytime you're solving for an angle, you use the shift.
Okay.
Yeah. Can you use the Pythagorean theorem to solve for an angle? No. So you have to use a trig ratio. Below, I don't know if we did this in this class. We didn't. Here are the three scenarios you'll have, and you'll have to decide which method to use. You have the Pythagorean theorem, and you have the trig ratios. Okay, you need to make sure once you've drawn a picture, you know what to do with it. So in the first, you're solving for a side. We have x, 5, and 23 degrees. Would we use the Pythagorean theorem or a trig ratio? Trig ratio. Because we have an angle. You can't plug an angle into the Pythagorean theorem. Which trig ratio would we use? We would use sine. So you can write that we would use sine. We don't have to solve for it. Just show that we would use sine because we have an angle, and you can't plug an angle into the Pythagorean theorem. The second, we are solving for a side, obviously the missing one. We are given 6 and 2.1. So would we use the Pythagorean theorem or a trig ratio? Pythagorean theorem. So you use the Pythagorean theorem. Last, you're solving for the angle of elevation. Where is the angle of elevation located? The bottom right. Finding an angle. So would we use the Pythagorean theorem or a trig ratio? Trig ratio, and which one in specific? Tangent. Tangent, and then you could even put a star next to this. You would end up using the inverse because it's an angle. Okay. So below that is just a reminder, I don't have it on my screen, but you have it on your paper, of what angle of elevation and angle of depression are. They both have a baseline of a horizontal line. Angle of depression looks downward from that horizontal line. Angle of elevation looks upward. Okay? When you're ready, we can flip to the last page. My first class of the day struggled with a question on their homework because they thought it had to do with this question. This is a hard question, which is why I'm doing it with you. Do you see how it says problem solving? It is harder than any of the ones on the homework. Do we understand each other? So this is not on the homework. Let's look. You're flying a kite with 20 feet of string extended. The angle of elevation from the spool of string to the kite is 67 degrees. A, draw and label a diagram that represents the situation. B, how far off the ground is the kite if you hold the spool 5 feet off the ground? Describe how the height where you hold the spool affects the height of the kite. So we're flying a kite. What are we standing on when we fly a kite?
The ground.
The ground. Draw the ground. We are holding a spool of yarn. So you're going to draw yourself. Drawing a ball cap because it's not a hair wash day. You're flying a kite with 20 feet of string extended. So a spool, looks like this. When you fly a kite, is it directly above you or is it a little bit of ways off? A little bit of ways off. So when you draw it, make sure you draw it more at an angle. Because kites don't fly directly above you, balloons do. Okay, you're flying a kite with 20 feet of string extended. So this string we just drew is 20 feet long. The angle of elevation from the spool of string to the kite is 67. So before we even talk about this, where is the spool of string?
In your hand.
In your hand. So from your hand to the kite, is 67 degrees. Remember that an angle of elevation always has a horizontal line as a baseline. So what you're going to do is draw a horizontal line. And this angle, 67 degrees. Okay, from the spool, which is the baseline for our angle, to the kite is 67 degrees. Okay? A, draw and label a situation. I think we've done that. B, how far off the ground is the kite if you hold the spool 5 feet off the ground? So think about this. There is 5 feet between the ground and the spool, which means this person is tall. 5 feet is like here, and I would never hold a kite all the way up here. So we want to find out how high off the ground the kite is. Here is the issue. The triangle is here, right? So if I were to find the height of the kite, I would only find from the spool to the kite, because that's where the triangle is. So what would I need to do at the end to figure out how far the kite is from the ground?
Find that side and add it to the 5 feet.
Correct. Find the side and then add it to 5 feet. Okay? Because we're going to find from the spool to the kite and then add from the spool to the ground. So we're going to use trigonometry, either the Pythagorean theorem or a trig ratio. We're going to use a trig ratio. From 67, what kind of side is the height of the opposite? And then 20 is the hypotenuse. Okay, so we're going to use sine from 67 equals the opposite, which is h, over the hypotenuse, which is 20. Do I need to flip this? I don't. Multiply by 20. We're going to round to the nearest whole number just to make our life a little easier. It's 18. So there is 18 feet between the spool and the kite. I want to know from the kite to the ground. So I'm going to take that 18 feet and add the remaining 5 from the spool to the ground, and that is 23 feet. Now, you won't have to describe on a quiz or test as far as I know, but if you did, you would just literally talk about what we did. We found from the spool to the kite, and then we added the 5 feet from the spool to the ground. That's it. So it says describe, that's what you would do. Okay? So, we're going to start on the classwork.